Hello, my name is Ibrahim Nako, and I'll be talking about fractals in this three-part series videos. You're going to go in depth about what fractals are, uh, the Mandelbrot set, and how fractals appear in nature as well, along with a few examples of where you could find more detailed documentation about uh, fractals themselves, along with tools that you could use to create fractals of your own. So let's get into what fractals really are. So the term fractals refers to an infinitely complex pattern that are self-similar across different scales, meaning they look similar no matter how much you zoom in or out. Fractals are created by repeating a simple process over and over in an ongoing feedback loop, producing intricate and beautiful structures. Fractals are found throughout nature in snowflakes, coastlines, ferns, lightning bolts, as well as in mathematics and computer-generated imagery. To understand what a fractal really is, let's look at some of its properties. As explained before, self-similarity means that each part of a fractal resembles the whole structure at different scales. Zoom in on any section and you will find the same pattern repeating no matter how deep you go. Also has infinite complexity. Fractals contain endless detail at every level of magnification. Unlike simple shapes, the boundary of a fractal becomes more intricate the closer you look, revealing its limitless structure. Let's move on to the fractional dimensions. Fractals have non-integer dimensions, meaning they exist between traditional dimensions. For example, a fractal curve can have a dimension between 1 and 2, reflecting its complexity and space-filling nature. It doesn't work normally as like a triangle or a rectangle would, where it has 3 or 4 dimensions. Uh, it only needs about one or two, because it loops a single formula over and over itself, revealing different patterns. Which here we talk about recursive patterns. Fractals are generated by repeating a simple rule or formula over and over. Each iteration feeds back into the next, producing increasingly detailed and complex structures from simple beginnings. Moving on to fractals in nature. Nature is full of fractal patterns, self-similar patterns that repeat at every scale. Here are some of the stunning examples we have in the real world. Snowflakes, fern leaves, coastlines, and lightning bolts are all examples of a fractal. A fractal generally is symbolized by a branch. So any branches that you see in a snowflake that repeats itself, that branches itself, can be considered a fractal. Some of the real world applications of fractals are here. Fractals are not just mathematical curiosities, they have powerful practical applications across a wide range of modern fields. Here are some of the most impactful real world uses of fractal geometry. Computer graphics. Fractals are used to generate realistic landscapes, textures, and natural scenery in most movies and video games. Mountains, clouds, coastlines, and terrain are all modeled using fractal algorithms. One of the more famous examples of this is Minecraft, where it's a terrain generation of a 66 by 66 million chunk borders, where all of it is generally generated by a fractal algorithm along with its parameters, adding to about which planes are supposed to be generated more or which biomes are supposed to be generated more. It gives about quadrillions more combinations of worlds than there are atoms in this universe. That's how deep a fractal can go. Medical imaging. Fractal analysis helps detect abnormalities in medical scans. The branching patterns of blood vessels, lungs, and neurons exhibit fractal properties, aiding diagnosis of diseases like cancer. Antenna design. Fractal shaped antennas pack complex geometry into compact spaces, enabling devices to receive multiple frequency bands efficiently. They are widely used in communication devices. And finally, let's talk about what brings us to the curiosity about fractals, why fractals are considered beautiful. Fractals reveal a profound truth. Beneath the apparent chaos of the natural world lies a hidden mathematical order, elegant and infinite. From the branching of trees and rivers to the spirals of galaxies and coastlines, fractals are nature's own design language, endlessly repeating, endlessly complex. This self similarity across scales shows us that simple rules can generate breathtaking complexity, connecting mathematics to the living world in a deeply meaningful way. Fractals remind us that beauty and order are not opposites of chaos, they are born from it. Understanding fractals means seeing the world with new eyes. Thank you so much for watching this video. In the next video, I will be talking about the Mandelbrot set, which is one of the more fundamental sets of fractals. I hope to see you there. Thank you so much.